Okay, welcome to the Learning Debug Early video. We're going to talk about how important and useful debug is for us. We're going to use our TP tools to create TP and add some layers for us. We're just going to go ahead and get started very simply, but we're going to go ahead and do some good production organization here. We're going to start off with a top-level dynamic set called test system. And then inside that, we're going to go ahead and save out one called birth. This is just an old habit so that we can save out test system as a black box in kind of a nice organized fashion if we want. We'll go ahead and use, let's say, a particle draw, because it's an easy way for us to just deal with one particle at the moment. Let's set its lifespan to 100. And we want to look at using debug, which is found here on the master dynamic under debug mode. Just click that and that'll turn it on. Opens up its little window here. This window layout is saved in your thinking INI if you need to modify it if it's off screen at all. Oops. And what we're going to do is we're going to create a second rule after birth, and we'll just call this test debug. And what we want to do is go ahead and just take a look at the simplest way that we can access debug information and kind of understand how it works. So we're going to go ahead and get the all group out here because we want to touch one of those particles who was created. We're going to touch this one who was created. It's assigned to all. So let's go ahead and expose its age output. And let's go ahead and add a memory operator. And let's add a scalar input. Go ahead and drop that down in here. And well, we're also going to go ahead and add an age variable. So drop that and make it available too. We'll make a connection from particle, or from the memory particle input to the particle of all. And so what happens now is all particles in the all group are sending themselves out and connecting to this memory operator. And it's important to remember all of the particles in all, no matter how many there are, make this connection and get affected by whatever they're connected to. But what we want to look at is we want to go ahead and take that age value and we're going to feed it both into the scalar and into the age. And then in order to actually see information appear here in debug, actually we will see some information if we just go ahead and scrub forward in time. We see that we get a t equals 160 and dt equals 160. What this t equals 160 means is that we are now on frame 1, and it actually debug info comes out as ticks. A lot of information in TP is internally stored as ticks, so that's why this happens. And so in our frame rate, which is 30 frames a second, and just a little remedial math, we've got 4,800 frames, or I'm sorry, 4,800 ticks per second. So if we divide that by 30, we get a value of 160. So that is why we see our, well, actually what we're getting here is our dt, which is our change in time. Our change in time, we're stepping forward one frame, and so that change value is 160 ticks. Now this current time, of course, is our current frame number in ticks. So 3 times 160 is that. Alright, so debug will show us some information without any values set up to be tied and shown into debug. But all it shows us is the time change information. What we want to do is go ahead and look at a specific value here. We're going to look at the output for age. We just right click that and say write to debug. And now it's kind of highlighted in this red color. That color, of course, is based on our schematic view color setup. But what we'll see now is as we step forward, we get the all value is sending out some information with its age. And it's very important to remember that in order for debug values to be shown, they actually have to be connected to something. And they have to be not just anything, but they actually have to end up being used. What this means is that we cannot simply attach age to this float value here. Let's see. Yeah, what we want to do here is is show that even though age is connected to float, this float value is not going to be reported. And it's not going to be reported because it's no longer, really being used. This float doesn't do anything with this age value coming in. In order for debug to work, we actually have to use this value in something else. If we were to use like a particle data operator, we could take that age and maybe feed it into mass. So as it gets older, it gets heavier, which tends to be the norm. But now that, and actually we'll disconnect those, now that age is actually connected and used by something, it will go ahead and show up here. Okay, so now you see our age equals that. We're going to go ahead and clear right to debug, which removes that indicator that tells that value to be showing in debug. And then let's go ahead and do this. The reason we use memory for common debug purposes is because it has access to so many different parameters types. And so we can show any of these that we need to and just kind of create a simple quick variable, add it here to the input list, and make that connection in order to see what this value or any value is doing. Yeah, alignment's a good one. We'll take a look at that too. Okay, so let's go back to age. One of the things we want to do with age in debug here is talk real quickly about, actually let's do this. Let's clear that debug, go back to 0. So at frame 0, what happens is this age output is being called or sent to the debug info. And it's actually, this age parameter is getting used twice. It gets sent out once to scalar and once to age. So it actually gets called twice. And because there's 2 calls, we get 2 versions of it here showing up in debug. If we were to go ahead and disconnect one of those, now of course we just get 1. So that's something else to remember. If you start to see a lot of multiple values in debug, it's probably because that value is being called multiple times. Okay, so we see here that age in TP, and you can see when we mouse over that output, we get an age and then parentheses age. That tells us that the data coming out of here is of data type age. And data type age looks like this. It's frame equals, ticks equals. It does that so it can keep track of all the ticks involved with a particle's life. Okay, but also, if we, let's go ahead and do this. Let's go ahead and write to, oops, not that one, but the scalar. We can actually see what that age looks like interpreted as a scalar value. And remember, TP, whenever we make connections between operators, if it needs to, it can automatically convert that data type if possible. So as we scrub forward, we'll see not only does age equals frames to tick 0, but when we interpret that age as a scalar, it automatically gets converted into just a value of 2. Okay, let's clear that right to debug log. Let's go ahead and make an alignment input and add that to our inputs. And then let's access our alignment value there and take a look at what the alignment of a particle looks like. Oh, well, we have to show that, don't we? Okay, so here we get an alignment equals, and what we're actually seeing here is a series of vectors, 3 vectors. We've got the 1 vector, the 2 vector, and the 3 vector, which describe the x orientation, the y orientation, and the z orientation, which many of you will probably recognize as a matrix. So the alignment coming out, of course, is a matrix value, and this is how it's stored internally inside TP. So really the useful thing about debug is anytime the system is not doing what you want it to, and there's some value maybe that is in question, and you want to test and look at that value to find out what exactly is going on, just make a memory operator, add a variable of the data type that you're dealing with, and then make that connection and expose it to right to debug log. and it will end up showing that information here in the debug log, so you can actually inspect the actual data that's being passed around. Okay, so this has just been a really brief basic intro to debug. We're going to be looking at debug certainly in quite a few other videos. But this is kind of the basics of how it works. This is what all the time values mean. Remember, it's in ticks. And yeah, it's a great way to see what is going on inside TP. Okay, let's move on.